Okay, let's test for absolute convergence here. So let's look at the absolute of an plus 1. If we call this here an, absolute of an plus 1 over an, that would equal the absolute of 2 to the n plus 1 over 2 to the n, x to the n plus 1 over x to the n, and then n squared over n plus 1 squared. That will equal the absolute of 2 times x to the n times n squared over n plus 1 squared. Now, the limit as n goes to infinity would have this go to, oh, I'm sorry, it's not x to the n, it's just x. That would become 1, that's still 2, so just become 2, the absolute value of x. And we need this to be less than 1, which would mean then the absolute value of x would have to be less than a half. But there's an inconclusive result when x equals a half. So consider x equal to a half then. We get the sum of 2 to the n over n squared times a half to the power of n, which will equal the sum of 1 over n squared, which converges to pi squared over 6. So this one turns out to be okay. And then we need to consider x equal to minus a half. We get the sum 2 to the n over n squared, and then that's minus a half to the power of n. So that would be the sum of minus 1 to the n over n squared, which also converges because the previous result is a well-known convergent series, and I wonder what it converges to. Not pi squared over 6. I wonder if I can find it. Let's see. I wonder what it converges to. I'm going to check here in some software. Anyways, let me just finish writing this off here. So therefore, the series converges when x is between minus a half and a half inclusive. Now let me just see what this converges to. If I can. Minus pi squared over 12. I'll have to remember that one. That's interesting. I'll have to try and remember that one. I didn't know it off the top of my head, like the 1 over n squared.